Greetings. Welcome to the lecture series of ordinary differential equation. This is lecture number 1 of that lecture series. In that lesson, we'll learn ordinary differential equation. This is an important mathematical tool to understand engineering and physics. The high quality study materials is attached in the description box for your convenience. Let's start the lesson with the question, what is a differential equation? An equation which involves any differential coefficient is called a differential equation, right? Suppose we have an equation d2y dx2 plus k is equal to y. Okay, this is an equation. It consists this differential coefficient, so this is called a differential equation. Now there are two type of differential equation we have. One is the ordinary and another kind of differential equation is a partial differential equation. Partial. What is the ordinary differential equation? If an differential equation involved only involving the derivative with single variable independent variable, then it is the ordinary differential equation. But if that differential equation contains more than one independent variable, then this is called the partial differential equation. Okay, now let's learn the degrees and the orders of a differential equation. What is the order of an differential equation? The highest derivative it contains that equation is called the order of the equation. Suppose we have an example d3y dx3 plus 3x dy dx is equal to e to the power y. Look at that example, this differential equation. Find what is the highest derivative of that equation. This is, and this is the third order derivative, so that equation is called third order differential equation. Third order differential equation. We got how to find the order of a differential equation. Now another question is how to find the degree of a differential equation. The power of the highest coefficient is called the degree of differential equation. Let's take another example. Y, okay, cube plus y plus y is equal to k. The what is the order of that differential equation? That is double derivative, so that it is second order, and the power of the highest coefficient is 3, so the degree is the 3. Okay, so this is the order and this is the degree of the differential equation. Let's try to understand that how to solve a differential equation by this separable variable method. Suppose we have a differential equation dy by dx is something we have that, say fxy can be written as minus p x by q y. This equation can be written as, we'll just do what, that will make these y terms together and x terms together. Okay, so that implies that q y dy plus px dx is equal to 0. So what we have done, we have actually just separated that coefficient in their term, respective term, x to dx and y to dy. Okay, now to find it, we have to find that integral of q y dy plus integral of px dx, and that is something constant we will get. This is called the separable variable method to find a differential a solution of a differential equation. Let's write down the general form of differential equation. How can we write dy dx plus px y is equal to f of x. This is the general form of differential equation. To solve the equation, let consider u x and another function of x vx. That u and v are the two arbitrary function. Okay. Now find the derivative of. Now substitute the value of y with this. Okay. What can we write? D of dx, the value of y is, now we got ux vx plus px uv is equal to fx. Now look at these terms. Let's do it. How can we find this derivative? This implies that v of du dx plus u of dv dx plus px of uv is equal to fx. So what we got can be written as p of du dx plus pu plus of u of dv dx can be written as fx. Okay. Now therefore, as that u and v are the arbitrary function of x, then we may choose that u in such a way that we can write du dx plus pu is 0. If you can write this, then that means that only that we can write these terms too. So let's write u dv dx is equal to f of x. We'll do it, we'll do this later. Let's first handle this equation, that du dx is equal to minus of pu. Therefore that can be written as, we can do what, the separable variable method. How? Du by u is equal to minus p dx. So this can be written as log of u. That can be written as log of u is equal to minus of integration of p dx plus log k. That log k is the integrating constant. Okay. So write down from this here, that so that u can be written as k e to the power minus integration of p dx. Okay. We got the value of u. Now let's find the value of v. We have that dv, value of dv is equal to fx of by u dx. This value can be written as 1 by k. Okay. E to the power minus p dx can be written as e to the power integration of p dx. The minus will be omitted, and that into fx dx. So we have find u, and we have find the dv. Now the value of v, we have to find that value of v. What will be the value of v? That value of v, the value of v will be integration of this term. K is the constant term, so it will be outside of that integration, e to the power p of dx fx dx, this plus an integration constant c. Okay, now we have the u and v both. Now we have the u and v both, so we can write that y is equal to, we have keep that u cross u dot v, so we have that u, that means k e to the power p dx, that is the u, and the value of v also we have that 1 by k e integration of it e to the power p dx fx fx dx plus that c term. Okay, we have this, so we can write it in that way, that a e to the power minus p dx plus e to the power p dx and integration of e to the power p dx fx dx. Okay, this is that we got it, that a mean kc, what is an arbitrary constant. Okay, and this term e to the power p dx is called the integrating factor. Okay, now let's learn the method of integrating factor to find a solution of a differential equation. If we stuck in a situation where we have already separated the variable but stuck to integrate the variable, okay, then we'll add something, or will some external factor to integrate this external factor is called integrating factor, that called integrating factor, and this integrating factor is written as pdx. It is that is written in that form. Okay, how we use this factor to find out a differential equation, solution of a differential equation? Let's go to the general is uh, form of linear differential equation, px y. This is the general form of linear differential equation. Okay, now we have to solve it by using the integrating factor. We have that integrating factor, if is e to the power integration of pdx. To solve this, we have to multiply this integrating factor both side, so that we can find something that we can something to integratable. Okay, now let's multiply both side with that e to the power p dx into dy dx plus px y e to the power p dx fx. Okay, we got. Now look at this can be written in that form, that e to the power p dx dy dx plus e to the power p dx px y, okay, is equal to e to the power p dx fx. That expression can be written in that form, d of dx y to the power p dx is equal to fx e to the power p dx. Okay, got it. Now if we integrate both side, we'll got e to the power p dx is equal to fx e to the power dx dx plus c, where c is the integral constant. Let's have an example to understand the concept more clearly. That if to solve the differential equation, first we'll make it in our standard differential form, that dy dx plus pxy is equal to fx. That is our standard differential equation form, and we have to make this differential equation into our standard differential equation form. Okay, how can I do? By dividing x log x for the both side. That will, so we'll get dy dx is equal to, sorry, that plus y by x log x is equal to 1 by x. So this is our, look at this term, this both, this is our standard differential equation form. Okay, now we got our standard differential equation form. So we can write that our px is equal to, our px is equal to 1 by x log x, and fx is equal to 1 by x. Okay, now we have the our px, so we can find the integrating factor, that is e to the power p dx. We have that integration of p dx, so to find the integration of p dx is equal to e to the power, what is value of p, 1 by x log x dx. Okay, so that is means e to the power log of x, so log x. So our integrating factor is log x. So how to solve it now? We got our integrating factor log x, so multiply both side of that equation with the integrating factor. Then that means log x into dy of dx plus y of x log x is equal to log x by x. This is the terms we need here. So solving this, so we can solve it in that way, log x, okay, dy, write again that terms dx plus y by x log x log x by x. Okay, these terms can be written as d of dx y of log x is equal to log x of x. So y log x is equal to integration of log x by x dx plus c. Log x by log x can be written, this integration is 1 by 2 log x square plus c. So the solution of is this. Thank you for watching.